Hi, welcome to today's 2020 Vision Hack live stream with me, Paul Wheels. I'm the product manager and developer evangelist for AD-Link. We've been working with Intel on the 2020 Vision Hack to find innovative companies and developers to build prototypes for industrial theme solutions using vision as a sensor. Let's take a look at the themes.
Let's take a look at the computer vision themes for the 2020 Vision Hack. Manufacturers leverage powerful, real-time data from the IoT to increase uptime, perform preventative maintenance, enhance productivity, improve mobile accessibility, and a host of other benefits, like fault detection and enabling higher quality production and quality inspection. Distribution businesses have requirements for asset management, business process efficiencies, and new business models. Considerations like warehouse management, tracking and tracing assets in real time, security and transparency, monitoring asset movement within and around the facility to prevent theft or the misplacement of goods. Workplace safety. Thousands of workers die in industrial accidents each year in the world, and a huge amount suffer from non-fatal work-related injuries. Workers, employees, and insurance companies collectively face billions of dollars of direct and indirect costs due to industrial accidents, and individuals suffer unnecessarily. For example, think about personal protective equipment, PPE detection, ensure people are wearing the correct equipment for hazardous environments. Fall detection, enable identification and notification systems when workers experience injury or equipment is damaged. The energy sector is adopting the use of computer vision to enable smarter, automated, and more effective sensor data collection. Actionable data available when and where it needs to be. Example uses are wind energy producers identifying maintenance such as dirt accumulation on wind turbines, dead insects and cracks in foundations or towers. In mines, automatic detection of anomalies in mines, for example leaks, fires, smoke, or even production blocks.
So they're the themes that the teams are trying to build the solutions with, and they're currently in the prototype phase of the hack using a Visi AI and Intel, which has the Intel CPU E3940 and also the VPU, which is the Myriad X, along with using OpenVINO. Today, we're very lucky to have Anna Belova, who's a deep learning software engineer, to talk us through a demo using Intel Devcloud. Hi, Anna. How are you?
Hi, everyone. I'm doing good. How are you today?
Yeah, I'm good, and I'm really pleased to have you on board today to do this demo. I'm really looking forward to this. Anna, you've had a really interesting career and journey to Intel. Can you tell us a little bit about your journey to Intel?
First time I was at Intel when I was a bachelor student. Intel in Russia has a program called Intel Summer Internship, when Intel invites the students to spend 2 months at Intel and choose and work on some task. So I participated in this program and I decided that I should work for Intel. And after half a year, I joined Intel as a more long-term internship and worked on Android devices. After that, I became a full-time technical consulting engineer and worked on Intel software called Intel Media SDK.
Right.
And after that, I switched the product and I started working on OpenVINO, and I'm still working in this project, but in different roles. So I was a technical consulting engineer, and now I became a deep learning software engineer.
Oh, wow. So your career has really been progressing through Intel and with the different technologies as well, really broadening out your experience.
Thank you.
That's brilliant. That's absolutely brilliant. Do you want to tell us about some of the tools that Intel have and what they make available to developers to help drive that adoption of new wave technology?
So today I'm working on Intel distribution of OpenVINO product, or just OpenVINO. This is the tool suite for developers. The aim of OpenVINO is to accelerate deep learning based algorithms or traditional computer vision algorithms on Intel hardware, because today Intel hardware is really different. Not only CPUs are available today, so we have graphics integrated or even discrete graphics. We have FPGA and special vision processing units or VPUs. What we sell under the Mavidius trademark. It's neural compute sticks and more bigger cards with several VPU cores. So this tool is really great in computer vision and deep learning. So it's not actually limited to computer vision. You can use deep learning with OpenVINA for other purposes. For example, for natural language processing or speech recognition.
And what type of with the speech side, which is something I recently touched on personally, what kind of use cases have you seen coming through, and what have you been helping with leveraging voice and audio compared to vision?
Probably the most popular scenario is speech recognition. Using different models like BERT, etc. And at Intel, we have special hardware unit called GNA. It's present on some of Intel CPUs, and it's really good for signal processing. But you know that speech is a signal. And so at OpenVINA, we support this device to process speech really efficiently.
Excellent. So you were going to talk us through Devcloud and give everybody a bit of an insight on there. If anybody has any questions, please do ask in the comments on the platform that you're on, and Anna will more than happily answer them through the course of the demo as well. So Anna, I'm just going to bring your screen in now, so to move on to your slide.
Yeah, sure. So first of all, just some very quick summary about what OpenVINA is. I already said that it's the toolkit for developers to accelerate computer vision and other deep learning powered tasks on Intel hardware. So I already talked about the high performance on Intel architecture, and other benefits are that we provide really high level interface, which allows to get acceleration. So you shouldn't be optimization engineer to accelerate your workload. And other very brilliant thing that this interface is the same for all the devices we support for CPU, for graphics, for FPGA, and for Mavidius hardware. So to move your application from one to other device, you just need to change one line of code, which is really helpful.
Yeah.
So with OpenVINA, you can very easily accelerate your workloads on Intel. And it was just a short reminder what OpenVINA is. So let's move to our main topic for today, which is Intel Devcloud for the Edge. So if you're interested to try OpenVINA and try Intel hardware, so what should you do if you don't have a wide range of Intel hardware types? And for this purpose, we created Intel Devcloud for the Edge. It's a cloud infrastructure where we have a lot of different Intel chips, CPUs from Atoms to Big Xeons, graphics, FPGA, Mavidius devices. And here OpenVINA is already pre-installed, so you can just get an access and start testing and evaluating OpenVINA and Intel hardware using Jupyter Lab and Jupyter Notebook interfaces, which are pretty popular today. You can use samples and demos we prepared. They are already available inside Devcloud. You can benchmark your own application and your own deployment model. Or you can just log in and start developing your own application. You can bring your model and evaluate a lot of devices and choose which one solves your task better. So let's move to the Devcloud demo. I just opened it in my web browser, so you can access Devcloud by the link devcloud.intel.com. And after you obtain an access, I will see picture like this. Here we have different opportunities. To get started, we have overview of OpenVINA and the Devcloud itself, and some more basic tutorials. If you are advanced user, you can learn our more complex sample applications and advanced tutorials. We also have some licensed applications, so these applications can be reused by you in your projects. Another interesting topic is Edge Insights for industrial capabilities. This is a software design reference created by Intel for the industrial and manufacturing. And if you click on Connect and Create, you access Jupyter Lab or Jupyter Notebook to develop your own application. And Deep Learning Workbench, which is a part of OpenVINA package. Workbench is a very nice graphical interface which combines a lot of OpenVINA tools, because generally OpenVINA tools are command line, but not everybody really love command line interfaces. That's why we created Deep Learning Workbench, which joins these tools' capabilities and provides very user-friendly graphical interface. Also, we have some announcements, what was added recently, and some resources like videos and other documentations explaining how to use the Devcloud, some news and forum. If we scroll down, we can check available devices, for example, and see how many devices you can access. So we have atoms, cores, Xeons here with different graphics model, and some accelerators like Mavideos or FPGA. And here there are a lot of explanation of how to use it, but right now I would like to demonstrate it to you. So let's go to the sample applications we have here, and here are a lot of applications which solves different tasks. So here you can choose the category. We have very basic samples, general samples, all samples which solve some vertical tasks like healthcare, for industrial, public sector, retail, security, or transportation. So let's choose the industrial one today. And here we have three applications: the safety detection, clean worker safety, and seismic interpretation. I would like to show safety detection because it's most recent one. So let's click on opening it in Jupyter Lab. So here, how Jupyter Lab looks like. So this is a Jupyter notebook, and the demo application is a notebook with some additional scripts and files. And to run the demo, you just need to click on the cells. So to save the time today, I already clicked on all cells, and I'll just show what we have inside. First of all, there are a lot of explanations of how to use this demo and other demos. All demos and samples have pretty similar structure. And the first step here is to import some Python models. So the notebooks contain Python code, and the first step to utilize OpenVINO generally is to convert the neural network model from framework format to the intermediate representation. It's our OpenVINO internal format of the model to use it with inference engine. And here we have MobileNet SSD trained to detect some safety gears, some safety equipment like vests and hard hats. So after we converted the model, we can move to the inference itself. Here we can configure some OpenVINO parameters like number of inflow requests. Let's look on the input video we offer in the demo. It's just people who walk near the camera. They wear some vests or hard hats. And if we scroll down, so when you log into the Devcloud, you obtain some, let's call it host machine. You can run the inference on the host machine, or you can utilize other available hardware at the Devcloud. And to utilize all the hardware of your choice, you need to create some jobs and run these jobs on the device of your interest. So, and the job creation script is here. We would just run safety gear detection Python script on devices. And job submission in Devcloud is done using qsub command, where we specify the job script, specify interested node, and other parameters. So this demo, we will run inference on Intel Core i5 processor first. We can monitor the process and progress here. Second device will be Xeon Gold. Xeon E3 is the third. Next one is the core again, but on GPU. Next we have also core device, but with Intel Neural Compute Stick 2. Atom with GPU, and Intel Vision Accelerator Design with Intel MyVideo's VPU. We can monitor job status here, so it's already done because I prepared it before. After inference is done, we can monitor the results from each device. So this is the inference result from Intel Core CPU. And you can see these bounding boxes. So the MobileNet SSD detects people and detects vests and hard hats. This is output from other devices. We won't spend much time on that. And next stage is to show the performance level for each device. So this graph demonstrates that. And this is the inference time, and this is the speed in frames per second. As you can notice that Intel design Intel card with 8 Mavidius VPUs is faster in this use case. But maybe you don't need to so speed device, so faster device. You can choose a device which meets your own KPI if you would assess this model for your application, for example. And the last opportunity which provided by this sample is a telemetry dashboard. So clicking on these cells, you can monitor the load of the system where you run the workload. It's also available for each type of device. Okay, it loads right now. So this is how safety geodetection sample looks like. If you would like to learn more about this, please get access to the Devcloud and try it yourself, or try our other samples and videos, or start creating your own application with Devcloud.
That's excellent. Absolutely brilliant. So once you've got used to using Devcloud and you've got some of the models and stuff working and you feel comfortable with that, how do you then move to a device like, for example, the AD-Link Visi AI device? And how easy is it to transfer that learning?
Oh, I don't see a big problem there. So you can just evaluate similar hardware in Devcloud and test it, and next order devices of your choice. For example, hardware provided by AdLink. So we have neural compute 6 in Devcloud, which is used there in the VZI, and similar CPUs. So that's not problem. You can download all the code. If you develop some application in Devcloud, you can download it to your PC and next reuse in your real project.
Yeah. Excellent. I mean, devices like Visi, which is available on arrow.com for $199. Definitely worthwhile checking out. It's a single board compute device. It also comes, it's not just the power of the hardware, but also the AD-Link Edge platform is included in there as well. So creating that flow of data from capturing imagery and getting that where you want to, and then bringing that, once you've created your model and managing that, you can then also then start to leverage that inferenced output data to then create reactions using Node-RED to turn lights on, send emails, so on and so forth as well. So it really takes it through. So this is a fantastic start of the journey of getting used to the tools to use, and also choosing the hardware balance as well, correct me if I'm wrong, within the Devcloud. But then you can start to move into the real world without making that investment. You can test and try, which is absolutely brilliant. We have a question from Alvarez. Thanks for your message. Hi. One, in order to continue using Devcloud after the trial period, will the use be paid? Will it be charged?
So good news here, because Devcloud is completely free. You can obtain the access, and next you can prolong it. So it's pretty simple.
Excellent. And the second question Alvarez has is how to access FPGA simulations.
Oh, it's not the simulations, it's an actual FPGA real hardware. When you log into the Devcloud, you will see the table. I showed that with devices available listed, and you can access it by submitting your job to the ID of this device. And I think it will be really easy. You can look examples in our samples. Some samples contain submitting the job to the FPGA and or read the documentation.
Excellent. And what you touched on lightly the forum there. So what support does everybody have within the Devcloud to help them through that if they have any challenges? Would you like to share your screen and show a little bit about the forum if possible and just what's available there?
I prefer just to
Yeah, sure, of course.
answer the question with the voice.
Yes, yeah, sure. No
because I already closed the window.
All right, no problem.
Yes, so you can just ask your question at the forum, and engineers from Intel will answer these questions as soon as possible.
Okay, brilliant. So it's a fairly reactive side of things. And do you have within the forum or community members also supporting users as well as Intel personnel?
Yeah, I hope so.
Yeah, and that's the beautiful thing about forums. We have go250.ai, which is the AD-Link computer vision and Edge AI community website. And within that forum, as it's progressed, it's nearly 1 year old now. We've got some phenomenal members supporting everybody and educating each other from their experiences and making recommendations of models and tools and so on and so forth. And that's really what helps us all grow and with our education on using these tools as well. Anna, thank you very much for your time today. Great demo, and the demo gods were kind to us, and we didn't have any problems, thank the Lord. So thanks very much for your time. We have a live stream coming up next week with myself, a number of Intel personnel, and hopefully some guest panel guests as well. And we're going to be talking about once you've built your solution and you've found the problem, and then start to think about how you would take this to market as a product. What's the challenges of being a startup and taking those, and even an established business as well. We all go through a learning curve. So we're going to talk about some war stories and also give some pointers on where to get some great support. So Anna, thanks very much for your time. It's been an absolute pleasure meeting you.
Invitation, and thanks for listening and watching us.
Thanks, and thanks everybody for watching. And please do get in touch. Oh, hold on, we've got one more comment. Here we go. Can we register as a person in Devcloud? Can we register VisiAI as an edge device in Intel Devcloud? Rama, and no, it's not in Intel Devcloud. If you were wanting to use some hardware, you've got the neurons, so you can go through that experience that way. Thanks for the question, and we'll wrap it up for tonight there. Thanks again, everybody, for joining us. Really appreciate it, and look forward to you joining us next week. Thanks, Anna. Bye-bye.
Bye-bye.